This week, Log4j exploit step by step in our first segment. Then Dragos Ryu, creator of Pwn to Own and CanSec West, joins us for an interview. In the security news, attacking RDP from the inside. Net USB exposed. The old mailing the USB drives trick. A persistent denial of service in your door lock. Signal gets a new CEO. Attacking the patching software. Where does that QR code go? And, no, not and. We heard you liked crypto miners. Pluton will fix that. And retiring from a jarring career. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly. For security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Keeping up with security issues across thousands of web assets without the right approach to web application security is a daunting task. Get ahead with web vulnerability scanning automation from NetSparker, a leader in dynamic and interactive application security testing known for its ease of use and accurate results. Detect a wide range of vulnerabilities in all legacy and modern web applications, address security bugs at scale by automating the confirmation process, automatically prioritize vulnerabilities, and assign actionable tickets to the right developers in their native workflows for rapid remediation. For more information on how to scale application security with ease, visit securityweekly.com/NetSparker.
Hi-ho, Kermit the Frog here. Let me introduce you to the host of our show, Mr. Paul Asadorian, a man who is also not green.
Welcome to Paul Security Weekly. It's episode number 723, recorded on January 12th, 2021, right here in G-Unit Studios in Rhode Island. Mr. Larry Pesce is here remotely. Larry, welcome.
Thanks, Paul. Yeah, gotta go remote. We had a pretty good epic trip over Christmas break, and, well, got the COVID.
Oh, you did get the COVID, huh?
Yep.
It happens.
Yep.
Looks like you're doing great, though.
It's all good, though.
It's good. It's good. Glad you're feeling well. Mr. Yes. Lee Neely is here with us. Lee, welcome.
Good to be back after a bit of a break. Had a wonderful holiday season. Now if we could just get all the snow off the ground so I could take down my decorations.
That's right. You had some pretty epic decorations, Lee.
Oh, thank you. It comes down quick, but it's hard to get it back in the box.
Yes. Mr. Josh Marpet is here with us. Josh, welcome.
Pleasure. How is everybody doing today?
Fantastic. Looking forward to a great show. Mr. Tyler Robinson is here with us. Are you off your conference call?
I am.
Sweet.
Good to be back. Missed you guys.
Yes, missed all of you as well. It's good to be back in the saddle. If you have a specific guest or topic you'd like us to cover on one of the upcoming shows, submit your suggestions for guests by visiting securityweekly.com/guests. We review those on actually like a weekly basis. So get your suggestions in so that we can review them. And now we're going to kick off the show, and we're going to talk about the Log4j exploit and walk you through how to do it, which is really...
That would be irresponsible, Paul.
I put a warning and disclaimer in the description, and I'll say it here on the show. Like, please use this information responsibly. Test in a lab. Test only with permission. Do not use this to do evil. Use this only for good. Please. Please. Because as Tyler can attest to, I'm like, Tyler, I'm gonna try and do this Log4j exploit. Like, I really have like nothing set up for it right now. I'm like, is this the best like exploit kit? He's like, yeah. Like that's a good one. I'm like, all right, here I go. And like less than an hour later, I'm like, woohoo, root shell. I'm like, that I am rusty, and I had to find the right license for my Burp Suite instance in that whole mix. And it still took me under an hour. And did I mention I was rusty? And I still got it working and had a root shell, which tells you how easy that this was the big takeaway really for me. I mean, other than some of these technical details, right? The big takeaway was just really how easy this was. And I'm like, oh my God.
So Rusty, what you're saying, it was really easy.
Yes.
Okay.
You may refer
Thanks,
to me as Rusty for the rest of the...
Don't end up on CISA's radar or FBI radar or any other radars for not doing this responsibly, because it is pretty easy to do.
It is. So, I mean, I'll just dive right into it. The first thing that, there's order doesn't necessarily matter as much when you're acquiring these things, but I was like, all right, the first thing I need is a vulnerable Java application that has this vulnerability. It turns out that's pretty easy to find. There's a lot of places you can find vulnerable Java applications. Again, only exploit them if you have permission. I went to Vulhub. Is Vulhub sponsored by a particular company? I don't remember now. It's like this collection of vulnerable containers. There's actually a few things in their GitHub repo. But I put the link in these notes that I'll post in the show notes and perhaps even put up in our own GitHub repository, and just throw these notes up there. GitHub.com/Security Weekly. So I went to Vulhub, and they have a Log4j vulnerable container that is pre-built for you. So what you do is you get the whole archive. So my archive was out of date, so I pulled down the whole entire collection of all of the containers that are in Vulhub, because it's a handy thing to have when you're doing testing. I unzipped those, went to the Log4j vulnerability, went into the directory CVE 2021 44228. I actually read the README too, which will come into play later on. You need a couple of snippets of information from that README. And to stand this up, it was really as easy as docker compose up-d. And lo and behold, on my local host on port 8983, did I get that right? It's in I'll read you the exact port number, that might be wrong. You've got a vulnerable Java application that is vulnerable to the Log4j vulnerability. So in just a few commands, vulnerable container up and running. Check. Now, there's a lot of exploits out there. There's a lot of exploit kits out there. And what's interesting is this exploit is not like, oh, I download some C code or some Python code and I compile it and exploit it. The reason they call it a kit is because this is it's a Java application that has the payloads, which are Java classes, that are available over they spin up a Jndi server and an RMI server as well. So what this exploit kit gives you is, once you spin it up and it's written in Java, so I pulled down the Jndi Exploit Kit, which was based on some other GitHub repository, and again, the link is right here in the notes. So I pulled that down. That gives you all the source code. They also make available a precompiled jar file, which I pulled down, and that's actually the one that I used. It's nice to have the source code if you want to make modifications to any of the framework, but essentially it spins up these services and gives you URLs that you place inside of your target, or use GET requests, POST requests. I even saw there's a header injection, right? Any way to get this URL basically in the logs of your Java application means your Java application will visit that URL, call back to you. This exploit kit has the Java classes that will then be loaded into that Java application, into that app, and then execute a command. So it took a lot of the work out that you would normally have to go through in one GitHub repository. Thank you very much to those who put that together. So I pulled down the jar file, which made it even easier because I didn't have to compile it. The one thing you have to do before you run this is you need to figure out what command you want to run. So when you inject or put the string that ultimately gets inside the logs, which is the Jndi server that it reaches out to pull the class down, that class will tell it to execute a command. And it depends on whether your target is Linux or Windows, what command you want to run. This command, which goes back quite a bit in history, I think I learned about it from Ed Scotus back in the day in one of the early SANS classes, on how to basically shovel a shell back when Netcat's not installed on the host. So since my host was running inside of a container, I couldn't tell to just connect to localhost, because localhost is local inside that container. It would never come out of the container. So I had to give it an actual IP address outside the container to shovel the shell back to where my netcat listener is. And so I'm telling it to execute this command, bash-i, the whole thing there, the ampersand with the pipe symbol, dev TCP, IP address, 8080, and then more bash command line stuff. And basically what this means, and I actually did a little bit of research. I traced this back to a Neo Hapsis post from 2008. Seems to be one of the earliest references on how to use bash and the TCP socket via a device file name to basically shovel a shell over to another host on a netcat. That host would be a netcat listener listening, right? It's hard to do without like actually typing it and showing it to you. It's kind of hard to describe. But anyway, you run bash with -i. That's interactive mode. The next bit of the command basically says redirect the interactive bash shell over a TCP socket via a device file that's handled specially by bash on a specified port. And then the last part of the command will copy standard in to standard out. So basically what that means is a reverse shell shoveled back to you. And I have some references that I link to in the show notes that go into a lot more detail as to exactly how that works. But that's the command that I want to run. So basically, when the vulnerable Java application loads the class, it'll execute this command. This command will connect back to me and shovel me a shell. So this is the command that you need to run. By default, the exploit kit will run calc.exe or something like that, some kind of a Windows command. I needed it to run a Linux command. So when you run you do java -jar Jndi Exploit Kit -C, and then in single quotes put your command that you want to run. In my case, it's that reverse bash shell that I described earlier, and then it'll spin up the exploit kit. So it'll tell you you've got an RMI address, an LDAP address, and it'll give you a whole bunch of I'm sorry, it's actually LDAP that it calls back to. It'll give you a whole bunch of URLs basically and a description of each. Like, hey, if your JDK16 whose trusted URL code base is true, use these URLs to inject into your Java application. So it gives you a whole bunch of URLs, and these are essentially generated randomly with random URLs every time you start the exploit kit. And it gives you a little log to track the activity. And these URLs, the RMI : / and LDAP : / URLs are what you're going to put into your request to the server that you hope gets into the logs, and then it will connect back to you. So I had to start up a netcat listener on port 8080 to have a listener on where it was going to call back to. So I ran the netcat command and listened on port 8080. So that's like the easy part, right? The hard part is figuring out in your application where you're going to put these special URLs. And thankfully, the README file for the vulnerable application tells me exactly where to put those URLs. So the payload it can basically be triggered in this particular application. And this is a Solr admin. This is like some vulnerable admin kind of Java application that they kind of just repackaged. And you just pull down basically the container image to run it. And they give you the GET request. So right here, if you can see it on my screen, that's where they say, this part I have in bold right here is the part you want to replace with your vulnerable URL, your LDAP, address, or RMI. Depends on what Java application is accepting and all that kind of stuff. So that's where the README is. The README gives you a location for that. So now, how do you get that GET request to include your callback string? Well, you have to use Burp Suite to modify the request going to the server to replace and basically inject your payload. I did create an alias for localhost called local dev, which was also a change in Chrome. Like, they're changing browsers even without a proxy, so they can't access things like localhost and local resources. And also, by default, Firefox will not allow you to proxy or request a local host. So I edited my Etsy host file to have an alias to my local host to connect to port 8983, where my vulnerable application was running. I'm sure there's a lot of ways to skin that cat. That's just the method I chose. So here's my vulnerable Java application, which is running there, which is some Solar management console of some sort. And then I talked about that. And then you fire up Burp Suite and you send visit that URL locally, local dev 8983 in my case, and you'll see a whole bunch of GET requests go across for the page. Very simply in Burp Suite, many of us have done this. You right click on one of those requests, you go send to repeater. Then you are in repeater where you can modify the request to be sent. You put in your vulnerable string, right? LDAP : / and the rest of the string that was given to you in the exploit kit. You click send, and magically, but not so magically, you then have a root shell on the system. Imagine that. So a lot of different components, right? You need a netcat listener somewhere. You need to have Burp Suite and know how to use Burp Suite to use repeater, which is pretty straightforward. You need to know the injection point in your vulnerable Java application. Then you need to get the exploit kit, which gives you the list of callback. I use the word URLs, right? Essentially URLs that you call back to. And you need to know the command that you want to execute. So, I mean, there's some, pieces here, but all in all, this is what it will look like. It'll get a little log like, hey, I got a request from your target, so I'm loading this class into that Java application because it called back to me over LDAP, and it sends that class over. That class basically executes the command that you give it. So I include some resources here. It is the Pimp's GitHub repository that has the Jndi Exploit Kit, which is very handy. One thing I didn't go into was there is an NSE script for Nmap that will discover this vulnerability as well. I did read that in kind of my research, but I didn't actually test it, but I thought that was kind of neat too. You want to find instances of this. And there's some creative ways in which you can find instances of Log4j in your environment. But this is how you exploit it. At least one way. There's a lot of different ways to skin this cat. Did I get all that right? Tyler, Larry, Lee, Josh?
Yep, that's pretty good walkthrough, man.
I think you gave a pretty good explanation, yeah.
That's
honestly the places that input fields live, and this is something that is just starting to, we're just going to start seeing some of the effects of this, because this isn't just an issue with RMI or LDAP. Like the JNDI interface and the way that kind of API handles those remote classes and the ability to load those remote classes is pretty pivotal for how some Java applications work. You have things like DNS in there. You've got even HTTP or what's a couple of the other ones? NIS. There's a bunch of different protocols that you can actually leverage for remote class loading and resources that are required by apps. So there's some good mitigations that SYS has put out around how to go about fixing this if your software is not being updated. That's one of the big issues that we've got is, many of these hospital applications, IoT devices, backend, ICS things have this integrated, and there's no good way to change out that Java class or update the Java library because of how it's flashed or how it's being used.
Yeah,
that and software vendors aren't doing it.
I got that wrong in the beginning. JNDI is the remote class loading, and it can load that over RMI or LDAP or other protocols. And that's what the exploit kit gives you. I mistakenly call that JNDI. It's not. JNDI is the class loading structure. And then how it loads that class is the specific other protocol.
Yep. Yeah, it's going to be interesting. There's a bunch of even stuff for there's going to be ways to detect this for blind, where logs get loaded or logs take a long time to load and it doesn't actually exploit, but there's still the vulnerability there. Things like DNS, where that's you're essentially sending the DNS protocol and getting a lookup to a domain you control that is coming out of a network that's blocking egress, but you're still able to see that it's vulnerable, the log loaded, and so you can do additional things in kind of sneaky ways, similar to like blind SQL injection or one of the other ones. So there's a lot that's going on still in the back end of this, and I believe it was reported that this isn't as widely exploited as for as broad as this exploit is and as dangerous and easy as this is, it's not being exploited as much, and we think that is kind of because we haven't even seen the full effect of where this lives and how it's being exploited.
Yeah.
So there's a lot going on.
And so how does the DNS component work? Do I still load do I load the class over DNS?
Correct.
How does that work?
Yep. And
Wait.
I'm not a Java developer, so like the back-end way of how that class actually is making it's doing a remote, I'm assuming it's doing a remote DNS request, depending on how you're utilizing DNS. It's doing a remote DNS class load over DNS for DNS functions.
Wow.
If I'm not mistaken.
Oh, okay. That's interesting.
Mm-hmm. So, did you have an environment where you could replace the Log4j, or did you have to stay with the static vulnerable?
I just used the container, and the container was a vulnerable Solr, SOLR application that Volhub had. I say packaged. When I took a look at the Docker Compose file, like it was really just loading it from a pre-built Docker image to load this application.
Yeah, they do a really good job. So this is actually, if I remember right, that's ran by Offensive Security.
I thought so,
or at least there's a tie-in there.
Yeah.
So they're kept up to date, and there's a lot of interesting packages and vulnerable things you can play with, and they do a good job of those.
Yeah, and it was running it in a container presented different challenges. I was like, oh wait, I got to shovel a shell, but outside the container. I had to think about my networking environment, because I wasn't running a lot of the tutorials that you'll see. They're running everything locally, so it's all local host, right? And what they call back to is local host. But if your vulnerable app is in the container, that's what tripped me up, was that local host was then now in the context of the container. That didn't help me. I had to have another IP address to call back to.
Which for really exploiting this, and we're talking about how to do this like for real, some of the challenges and points of remediation or detection come from the fact that these remote class loads are going to external resources, and so you've got the opportunity with egress rules and filtering. You have the ability. With that being said, though, there's also a lot of active real-world exploitation happening to like Cloudflare. Like if I was to do this, I would use something like Cloudflare or ngrok and have those redirections happening to legitimate domains or cloud-fronted domains, which is what we're starting to see. And so your ability to kind of base the legitimacy of these requests on known malicious domains versus things that are like an S3 bucket, which there's an APT group utilizing the loads for the PowerShell stage 1 from an S3 bucket, which is a categorized domain. It's valid. It has a valid cert. So there's good detection points, but there's also a lot of caveats to how you do this for real, because you're not just doing this to local hosts. You've got endpoints that have to call out. Maybe they're running through proxies. Maybe they're in the context of a container and they have a limited user, and that user's context is also being shoveled through a different process or container. So there's kind of a lot of interesting issues with how you test this, and false positives and false negatives.
Yeah, because the target has to, like in my case, reach out over an LDAP protocol, and in for reals, like out to the internet. And so egress filtering could be useful in thwarting some of these attacks, but
But no one does egress filtering, right?
Yeah. Okay. So is that still
Who
that's
does
still
egress filtering?
No one does egress filtering. Okay.
Yeah. No, and then again, that goes back to some of the other interesting protocols that I don't think have fully been explored, and we're still just starting to kind of mess with when you start to talk about like HTTP, HTTPS, or even secure LDAP, which the RMI or JNDI does support. So
yeah, so there's a bunch of different protocols you can use to call out and load a class remotely. In other words, it's interesting. Well, and there you have it. That's just one example. I think what some of the pretty amazing things are about this exploit is the number of ways in which it can be triggered and the number of ways in which you can call back, and then how creative you can be with the payload or the command that's run, which also makes it super hard to detect because there's so many attackers are creating so many variations of this.
Yeah, imagine all the endpoint input fields in something like Apple, or even just Apple software. You start to look at different reporting of help, or file a complaint, submit a ticket. All the different endpoints in which there's a place to do input in a field, or to have a GET request or a POST request back to somewhere that may be running something like Log4j. Like all of those can be fuzzed and input. You look at the Apple when this first came out on day one, people changing the name of their Apple phone. That's obviously being logged. That's a very creative way that someone is logging something that is not actually a direct input field, but it is a user modifiable field. So now think about all the hardware and user modifiable fields that are available in any game, application, web service. Like this gets pretty deep, and the rabbit hole goes very far.
Yeah, because it's not the application doesn't necessarily have to log it, but something that's logging that application, like you can follow the chain. Like I submit something to this system, that system doesn't necessarily log it, but that system sends it to another system that is logging it. And like there's these chain. How deep do you want? Not that you want, but how deep could that exploit go into these various systems and organizations?
A web app that calls back to a database that then has a tie-in for metrics or analytics that is loading a library that was Log4j and maybe not even an exposed Java application. Like there is a pretty deep chain of, which is why the government's so big on the bill of services. Like where does this library exist inside of our software structure and the applications using our software? That's why it's so important and such a big deal and so hard to kind of keep track of. And that's why there's a big push.
Yeah, can I give you an example? Did you guys talk about the Python issues with this?
It does. Log4j is you can implement it as a Python library.
Yeah, because Python has apparently really crappy logging. So
there's
I had to put up the background.
No, but I use a logger log. There's a log. It's really complicated. I thought it was really complicated, but I don't have a lot of experience with these logging frameworks. But when I inherited our Python application, it used some logging framework in it that I can't remember. It's one of the standard like Python ones. But you could use Log4j in. I guess to your point.
There's integrations built to use Log4j in Python. Any Python application or Python relevant application, anything you can add Python to. Most of the Python logging systems are meant for single developers, not really enterprise teams.
Yeah.
And so Log4j, people like, wait, I can just build an integrator, and somebody built a bridge, and boom, now you've got enterprise grade logging for free. So
there you go.
This is fun.
It's really bad. It is. That was kind of my assessment of the whole thing. I'm like, this is really bad.
I mean, you think about how prolific this is, and like what's the next closest exploit that is so well spread across multiple platforms that gives you remote code execution and is integrated as something like a library? We had to probably think back to maybe Apache struts. It's been a while since we've had something that is this bad and widespread across not just Windows. We see this for Active Directory, and we see a lot of things that happen, but fully remote code execution, full ownership, root level, from a basic string that is not a hard to implement exploit. Like that's probably struts is the last thing I can think of.
Mm-hmm.
I think I hear Lee trying to chime in back there somewhere.
Yeah. So I'm wondering what some of the things like the, CISA released a scanner for Log4j. I'm wondering what it looks like when you poke it at that container you've got. And it also has the hooks for the DNS, so you could actually experiment with that. It can use your own DNS. It can use Interact or Canary tokens. So, and we know Canary tokens is kind of cool. So
I know a lot of people are using Canary tokens, right, to trigger this. That's a pretty common method in speaking with people, because you basically load a class that hits a Canary token. Like your payload is basically go touch this Canary token.
Honestly, like the first week or two, if I was a nation state of any size or capability, I probably would have had all kinds of honeypots and crazy stuff out there that should be mapping very quickly stood up nation state and or threat actors infrastructure, because they're probably not going to have time to build a bunch of new stuff, and they've got to have payloads and things to call back very quickly. So it would have been a good opportunity to find and map out a large portion of the internet's threat vectors and threat actors that are abusing things or using other things to abuse things, which would have been interesting research as well.
Agreed.
So, by the way, when my developers discovered Log4j years ago, they were like in heaven, because logging effectively in Java basically sucked. So, kind of blows.
It's interesting.
So bad.
It's interesting. This was discovered back in 2016. There was two gentlemen that I can't remember.
I have it. No, I have it. Keep talking. I'm going to read it to you. I have it saved.
They found this with RMI, and they even referenced the LDAP and the abuse of this remotely to load classes. Like, this has been known.
Yep. Black Hat.
They presented at this at either Black Hat or DEF CON, didn't they?
Black Hat 2016.
Black Hat USA 2016, a journey from JNDI LDAP manipulation to remote code execution dreamland. Alvaro Munoz and Oleksandr Mirosh. Yep.
Very nice.
Yeah, it's a very good presentation. They cover it really well. They do talk very quickly, and they do get very technical very quick. So it is. You should probably have a little background knowledge before watching that one, but it's not new, and it is interesting that didn't get picked up on or even noticed as part of a widespread library that's being pushed, because they clearly call it out as it is and as it's been reported today. So, and I don't see a bunch of references to them, which is also interesting.
Yeah, I'm glad I saved that, and we could mention them by name. And RMI also plays into, is it Tomcat that uses RMI as well, right?
No. Is it?
Yes, it's Tomcat. There were some exploits with
You're right.
RMI,
Yes.
Tomcat. Yeah.
Tomcat, and there's a couple others that are similar to that are very widespread. It wasn't Chef, it was one of the other ones. Yeah, there was a couple others that were like, this could be really bad if this happens.
Yep. Cool.
Now, Paul, stepping back to this one, when you did your attack with your Docker container and the burp stuff, what part? And I missed it. What part of the URL were you putting that in, or what part of the request were you putting it in?
Oh, it was just in the GET request.
Okay.
So it's get solar admin cores question mark parameter action, and in the action parameter is where I put the JNDI colon and then the LDAP URL.
Okay.
Yep.
Okay. Because I know in a couple of cases that finding some of these vulnerabilities might get kind of interesting, and again with permission, and this becomes kind of crazy. But by using like a user agent switcher on your browser and putting that JNDI string as your user agent in your browser, and then just start surfing the web.
Yes.
Yeah.
Because user agents are logged.
Could be. Yeah. Should be.
Usually, right?
Right.
Yep. Yeah, there's a lot of that's part of the badness of this is there's a lot of injection points.
Yeah, there's a lot of attack surface.
Yep. And a lot of Java applications still out there. Because this wasn't just, I described it earlier today as you got your custom homegrown written Java applications, and then you got the stuff you bought, which you may not even know that it has a Java application that was implementing Log4j, but it's there somewhere, and you may not even realize that it's there. Unless they have an SBOM, which everyone has an SBOM now, right?
Which,
Josh, doesn't that come with software as standard
No,
now?
they do not.
I thought Alan made everyone have that as standard, and everyone listened, right? They should.
Yeah, everybody's supposed to. However, Alan and I love Alan dearly, and I want there to be SBOMs everywhere. But no, there is not. We're working very hard to get SBOMs all over the place. I'm working with SPDX. Alan's working at CISA now. There's a lot of things going on, but no, SBOMs are very rare and very, very behind a lot of paywalls or a lot of NDA walls or whatever you want to call it.
Right.
It's actually a pain in the ass. And everyone's like, so why should I do an SBOM? Because if I do it, then my vulnerabilities are exposed, but his isn't. He didn't do an SBOM. And it's like, yeah, everybody's got to do it. But why? And I think that it's going to tie down to, I won't go into my rant, but I think cyber insurance is going to be a big part of that.
Yeah.
We'll see.
Yep.
Josh,
I agree with
my big one, if you don't have an S-bomb, you're going to have a lot of F-bombs.
Yep.
Yeah. I am making that a sticker. I am making that a sticker.
That's a great sticker.
Yeah.
S-bombs, lack of S-bombs lead to copious F-bombs.
What is it, Sticker Mule?
Yeah, Sticker Mule.
The amount of big, widely spread affected large scale software, like things you wouldn't even think of. VMware is a great example. Like some of the software applications that VMware is using for like Horizon or even some of their API calls, like that's a pretty big day because that's exposed to the internet. So we think about all these like, okay, so it's Java applications, but really where Log4j is integrated into large applications, if you look on CISA's affected software list, like the number of very large companies in there that are affected, and some of them affected and fixed, most of them not fixed yet or in process, that's a pretty big list. You start to think about PLCs and all of that stuff.
Yeah.
It is massive.
Go back to Larry's example. So I got my user agent string set, and I'm hitting a bunch of sites, but it doesn't have to be. It could be the internal network because I have Security Onion, which logs all of the user agent strings, and Security Onion, I mean, it included the vulnerable component as part of Logstash and one other component, and so like you could pop the Security Onion instance just by getting it to observe your traffic anywhere, right? That could be logs on a host, that could be traversing the network, and now you've just gotten a shell on the...
Think about what loads automatically in a web page and the backend applications for like ad tracking and the automatic CSS that loads as part of whatever analytic you're using for ad tracking. All of those potentially log things and call back to a separate app that could have a Log4j library embedded into it. Again, it's not necessarily just a Java application. It is the fact that these companies, as they're building software and they're building packages, they're looking for something to do logging in their application. They may just be using that library. And so, like I said, it's integrated in so many things that it's just scary.
I think it's worse than that, Tyler. I was reading an article that Apache Maven Central had counted like 4 million downloads of the vulnerable Log4j, as if the people weren't updating their CI/CD and qualifying the new one. So they're just building with the old one. They're not moving forward, and then it just gets pushed out to the consumer.
That doesn't surprise me. You look at all the PLCs and the things like Schneider Electric or any of the other vendors that are doing ICS stuff. The list of ICS devices and things that are going to be in the field for a very long time and don't have an easy way to update something like an affected library via firmware push or even an image for the real-time operating system. Those things are going to be affected and probably will remain vulnerable for a good portion of time. And I don't think we're even going to find, whose water department is looking for Log4j and has an understanding of what devices are installed and in the field. Not many. Like they're barely able to do the remote software and figure out that they got to keep Windows up to date. So, it's going to be a long-standing issue.
I'm thinking the unit of measure is going to be years, not months or weeks.
No, I agree. And updating this stuff is not easy depending on your application.
No.
Updating a library could be easy, could not be. Right? It all depends on your application. I've had to do this with several components within our own application. Like, you get into dependencies. Like, but if I update Log4j, I got to update this other component, or if I update this other component, I got to update Log4j. So you get into dependency hell with all of your components. And sometimes the answer is finding the right versions that work. Sometimes it's to get to the latest level of all of my dependencies. That means this one thing just won't work at all because the developer hasn't updated it to work with the other updated components. So I've run into the situation, I think I was telling Mike Shima in Slack earlier this week, I've run into where I've updated everything and this one library for WordPress just doesn't work anymore. And sometimes that's not even within my own application. It's WordPress has updated their API and the library I have to interface with WordPress hasn't been updated by the maintainer. So now I have a choice. I can become the maintainer and I can fork this and become my own maintainer of someone else's code and try and modify it so it works. And several hours down that path, I realized that was the wrong path. Or I can write my own library, which I did in less than the several hours, maybe roughly the same time. But I only implemented the portions of that, API that I was using, which I think is a little more secure. I'm only implementing the calls that I actually need, and I can put my own error checking and processes in there. And so now you've got to rewrite a library. That doesn't just happen, right? Because then all the points in my code that reference that library have to be regression tested, and that takes time. And this is just a relatively small application compared to some of these really large enterprise applications that are including Log4j. So just saying, we'll just upgrade to the latest version is not always the answer.
Well, I mean, let me ask you a question. So Leah, did I hear you right? You said basically it's going to be, potentially months or years before this is remediated across at least a pretty big section of the internet, right?
Well, I'm thinking a lot about IoT. Yeah.
Well, yeah, okay. So let me back you up on that. Like I have family members that are medical professionals. They deal with X-ray machines. And the last time I was over there, I'm like, why is this X-ray machine running Windows 7? And it's because they can't upgrade. They don't own the X-ray machine. They lease it. And the X-ray machine company will not upgrade it because it's FDA approved at this specific patch level. And to get it reapproved with Windows 10 or Windows 11 or Windows whatever, that would cost them a lot of money. Like, screw it, not happening. And by the way, it's on the internet.
And not to mention the money, but also the time for that to happen. It's easily a 8 to 9 month process.
So, okay, but Windows 7 was end of life a little more than 8 to 9 months ago. Let's be clear. I'm not, Larry, you're right. I'm sorry. But I mean, they've had the time to do it, but have they had the will to do it, the money to do it, the reason to do it? And the answer is really not. Right. So honestly, I'm thinking this is never going to go away. I mean, hey, Larry, let me ask you a question. Mr. Deals with ICS SCADA stuff on a vaguely regular basis. A Blaster and Configure, are they still around?
They certainly show up in my logs. Like you still see like all these types of things pinging stuff, like whether it's legitimate stuff that's been compromised or it's still stuff that's just honeypotish. They're still out there.
I was talking to, was it Chris Sistrunk? And Chris was telling me, and this might have been about a year or two ago, but Chris was telling me that, or it might have been Jim, I don't remember. But it was like, what's the biggest danger in power systems besides squirrels? Let's be clear. They are the most dangerous thing to a power system known to mankind. But besides squirrels, it's Blaster and Configure because nothing's been updated. Nothing.
Right.
Okay. And how long has it been since anybody, like Tyler, how long has it been since you had that in your, used, I know it's in your arsenal, but how long has it been since you've used that on a regular basis? You know what I mean?
Yeah, a long time. I mean, Eternal Blue is another good one that still affects a lot of systems, and it typically is in something like medical or ICS that we see this, because those devices, A, either can't be updated because of FDA approval or licensing, or B, there's not enough money for the replacement, or the replacement is actually part of a larger project that cannot get done without certain controls, pass-offs, governance, all of the things that usually stop these big organizations from doing really quick responses to things like this. So yeah, this is going to be around for a long time, and it's going to be things like medical and ICS that probably suffer and probably will not be able to do anything for a while. I foresee ransomware leveraging this in their kit as part of their way to hold something to someone's head and tell them to do things.
And I'm going to point out that in Discord, by the way, if you're not on the Discord server, join the Discord server. Dimitri's on there going, hey, you hope that people on the ground, the boots on the ground, have set up decent IPS and exit gateways to add compensating controls to the woeful vendor support on those systems. And he's right. If you're not adding compensating controls, I'm sorry, go ahead, Larry.
And cue the evil laughter because they haven't.
Aw, you're such a pessimist. Paul,
but they haven't.
Paul.
No, it's a realist.
Yeah, I know. Paul, on your amazing systems there at G Unit Studios, you have set up a perfect intrusion protection system, right?
Yeah. Yeah.
No, you haven't, Paul. He said perfect.
Nothing's perfect.
He said perfect. Hey, bingo.
I mean,
you did a really good one. Right?
Check the logs occasionally, which, I do use Security Onion, but when I'm not doing a segment on it, I don't always check it, which is bad. Being a one-man security operations has its challenges, right? Yeah, but I mean, that's a lot of the places you guys are talking about, right? Municipalities, water, power. Oftentimes they are resource constrained, and there is only one person, whose security is part of their job, right? Until that happens, and there's going to be Java applications that have this library in it for a really long time, and it's going to be vulnerable for a really long time.
I mean, hell, there's textbooks that are going to, tell you use use Log4j for this and that and the other thing. And by the way, use this version. I mean, never mind. It's horrible. It's just effing horrible.
So use the exploit responsibly, and hopefully you patch your stuff where you can, and hopefully if you don't, you have compensating controls. And it's gonna be a long road, as we said. So many ways to exploit this, which is going to be really interesting. So, with that, we'll take a short break. Come back with Dragos, founder of CanSec West. Stay tuned.